continue working with where I was. Okay, now this is like kind of, all right, let me see here. Okay, let's see. Okay, like they are making a survey, it seems. Okay, anyway, I will continue with chapter 3. I intentionally stopped here and didn't complete this one because this one is this part here where you need to calculate the resultant of these two vectors and find the direction is going to be your exit ticket number 3. Then exit ticket number 3 is going to be to calculate the magnitude of this resultant that I did work on here, and to calculate also its direction through calculation of the angle. This one also, it will be submitted through Canvas to go to Gradescope, where you're gonna upload your work as a, I will say the free response work. All right. And now here, there is one problem where we have a delivery, a truck travels 14 blocks north. Like I can easily maybe like draw something that is gonna give me an understanding of this problem. Then I will say, all right, I have like 14 blocks, okay, north, and then east, 16, then here it should be and then 16 here, and 26 south. Okay, here I will not be able, I don't have enough space to finish it, but let's assume something like this. I can say this is my A, this is my B, this is my C, which is gonna be 26. And what is its find displacement if all the blocks are equal? What I'm looking for is this vector here. Okay, then this is the vector that I'm looking for. Okay, now this is gonna be the resultant. Okay, now what I can do is I can do the addition based on the angles. Then I will, okay, let me add one page, not here, after this one I will add. Okay, then okay, the first one is 14 units along X. Like I can easily here, just for the purpose of the demo, say like this is my A, it is something like this. Oh, sorry, north. I said along X, it should be along Y. Okay, then this is really the 14. Now the second one, it is due east, which is B, then this is A, this is B, 16. And finally, there is another one that is gonna be south, 26. You can simply, I will say, get rid of the 14 by saying along the Y. There are many methods of like thinking of this problem. Along the Y axis, then I have, like, I can get rid of this 14 units minus 26 units equal, when you subtract, is going to be negative 12. Then you can say that this is going to be just 12, and like, you know, this one is 12 and this one is 16, and this is like can be done using the Pythagorean. Then I will say this is my vector here, and then this is gonna be my resultant. I can do this, okay? I can do it also in like different I will say methods. I want maybe to show you my this method. I feel it is peace of mind, that is you don't have to think a lot about like I need to subtract, I need to add, I need to do, you know, like it's just kind of systematic method. Then I will say here, okay, this is what I will do. And of course, all the solutions, they're gonna lead to the same answer. This is A, B, C. The magnitude, you can make it meters, blocks, whatever, like units, okay? And A, it is 14, B, it is 16, and this one is 26. Now, I can translate south, north, east to angles, which I always prefer, maybe. Then I will say A is along the y-axis, the positive, then it is 90. And B, it is along the x-axis, then it is 0. And C, it is along the negative, then it is 2, as negative y, then it is 270. And here I can say x component, y component. Now for the x component, I will say is gonna be like 14 cosine 90, and this one 14 sine 90. I want you just to remember that the cosine for 90 is 0, then this is gonna give you 0, and this one is gonna give you 4. Then I will say sine 90 is 1, sorry, then it's gonna give you 14, I mean. Okay, and here I can say this is 16 cosine 0. Cosine 0 is 1, then this one is going to be 16 meters. And here I will say it's going to be 16 sine 0, and sine 0 is 0 then. And it's very clear because whenever you're going to have anything along the x-axis, it doesn't have any component in the y. Anything in the y will not have an x component. And finally here I will say 26 meters cosine 270, and cosine 270 again is 0. And here 26 meters sine 270. Sine 270 is negative 1. And finally, we will add the components, Rx and Ry, like, oh, sorry. This is Rx, and this is Ry. And that one you're going to add all together, 16 meters, and this one 14 minus 26, which is negative 12. It's the same results that I got here. And then I can say R is going to be the square root of Rx squared plus Ry squared. Then it is going to be square root of 16 meters plus negative 12. Okay, and then you're going to find the square root. And for theta, you're going to find tan inverse of Ry over Rx, which is going to be negative 12 meters divided by 16 meters, and you will find what is tan the inverse. Okay, now in my drawing, this is my theta that I'm gonna get, and you can find this angle or the other angle, that's okay. Now, given here A and B equals C, and that A times 2 plus B times 2 equals C times 2, because when you multiply with 2 everywhere, how are vectors A and B oriented with respect to each other? Now, what does that mean? That means the question is asking you, if we are going to multiply by a constant, how this is going to affect the directions of the vectors, okay? And I will say here, if we are, okay, how are vectors A and B oriented with respect to each other? Okay, now I will say here they should be perpendicular to each other. Why? Because we will say that the magnitudes of the vectors satisfy the Pythagorean theorem, which means here I have right triangles, and then the vector C is going to be the hypotenuse, A and B, they're going to be the sides, and then therefore they're going to be perpendicular. Now, if each component of a vector is doubled, what happens to the angle of the vector? Now, this is here how this is going to affect the vector. We will say it will not change because all the trigonometry constants are really ratios. Then the ratio is going to cancel because when you will say 2b divided by 2c is going to be b divided by c, then it's not going to be changing because it's a ratio that is going to be the same. Okay. Now, another topic here, it is unit vectors. And when we talk about unit vectors, these are really dimensionless vectors that they have unit length. They are really along the x, like you will see here that we are using that x unit vector. Usually in other textbook we are using I for x, I unit vector, and it has a length of 1 unit from its name, so that it will not affect the magnitude. And y unit vector, we usually call it j, and also it has a length of 1. Now, I will say it's a very convenient way to express vectors and unit vectors. It's going to make like the calculation very easy. Then I will say if I have A equals 5 meters x plus minus 2 meters y, and B is negative 2 plus 5, then simply when you're gonna add A plus B is gonna be 5 minus 2, 3, and negative 2 plus it's gonna be 3 again. Then this is how we're gonna find the vector. Of course, this is to calculate the vector in unit vectors. If you wish again to calculate the magnitude of A plus B, you need to do the Pythagorean again. Okay, like this one here squared plus this one squared, and also you can find tan inverse for that vector if you wish to calculate also the direction. Of course, here we will say that again, position, displacement, velocity, these are really vectors. And then if I have my object located at an initial Ri like this, and then it did move to another location here, our final, in order to find the its displacement vector, then we should move here, because now the displacement is gonna be R final minus R initial. Then you subtract the two vectors, then you can actually say, if you put the two vectors with the tails together, you can say that delta R, which is I wrote that it is gonna be delta X. Oh, why delta X? It's gonna be delta R, is going to be from Ri to Rf. Here also working with the average velocity vector, where I have delta R here, and then because V average is delta R over delta T, okay, it's gonna have the same direction as delta R because delta T is a scalar. Now we know that the instantaneous, again, if we want to compare instantaneous versus average, the average is going to be the slope of the chord versus the instantaneous is going to be the slope of the tangent at this point. Now also we can say the same with velocities. Then if I have with accelerations, the acceleration is the change of velocity with time, then I will say here V average is going to be V final minus V initial divided by time. Then the vector that is going to be delta V is going to be from Vi to V final, and it's the same direction as the acceleration, because again the time is a scalar. Now I will say whenever we are talking about the direction of the motion, we are talking about the direction of the velocity vector. It's not the acceleration vector. The acceleration vector can point in any direction. For example, here, if I am talking about that the object is moving from this point here to this point here, at any instant you can find the velocity vector by the tangent, all right? And the velocity, I will say the acceleration can be anything. Here you can see in like point number 1, I will say A is in opposite direction of V, which means here speed decreases. And then I will say at point, this is 1, at point 2, now velocity is perpendicular to A, and this one, it is centripetal acceleration. It is needed so that the object is going to stay on the curve without changing its velocity. Okay, and then also I will say at 3 it's the same, but at the last one, number 4, velocity and acceleration are in the same direction, which means that I will have speed increases, or velocity is going to increase. All right. Now, I will say here, this one, this problem here, I will leave it for you to try it. We have a skier that is accelerating down an inclination, okay, or like just an inclined, like this. And it is 30 degrees. And the acceleration is 3.8 meters per second square. And we are asking what is the vertical component of her acceleration. Okay, then this is just, I want you to work on this problem, and if you have any questions, bringing them to me here. Like any vector, we have component X and Y component. How long would it take to reach the bottom of the hill, assuming she starts from rest, accelerates uniformly if the elevation changes, like she's changing her elevation by 335 meters. Okay, then this is a problem that I want you to try, and then we can work on the solution if you like during office hours. Okay, now adding vectors, it is gonna be like good to have that kind of relative motion to talk about. Just, I'm gonna put up my water here. Relative motion is one of the applications that we need to focus on as related to adding vectors. Then I will say here, remember we were talking at the beginning, that is your frame of reference is very important in your measurements or your calculations. Then if you are on, let's say, an observer that is stationary, that it is at the outside the train here, you're going to measure a velocity for that worker inside the train to be 1.2 meters per second plus 15. Then but if you are inside the train, you will see that worker moving with just 1.2 meters per second. Then I will say this is 16.2 meters per second. And I will say, if we are going to have that observer again outside, but now the worker is moving in the opposite direction of the train, then the observer is going to measure on the ground 15 meters per second minus 1.2 meters per second. Okay, and then this is going to be 13.8. Now we can make, now this is just one dimension, which is gonna be very easy maybe to handle with, because it's like the velocities, either you're gonna add them or you are going to subtract them. But just here, I want to add one more page here just to explain to you some of the notations that we are using with relative velocity. Now, I have different, what is called a frame of references. One of them is the train, T. Now, I will say here for the person or the passenger, I'm gonna refer as P. And for the one outside, which is on the ground, I'm gonna refer to it as G. Okay? Now, if I want to find the velocity of the passenger with respect to the ground, then like how the passenger, how the person on ground is going to measure the passenger's velocity. That one is going to be the velocity of the passenger with respect to the train plus the velocity of the train with respect to the ground. This is the equation that we are going to use, and this one is general. It's not only connected to one dimensional. And like to make it easy for you to remember, this is P over G, and that one it is P over T plus V T over G, just to verify that you are doing the right thing. Look here, the T is going to cancel, and then you're going to have PG again. All right? And now here, this is adding vectors. Okay, then you are going to follow rules of adding vectors for two-dimensional problems. Like, okay, where are we going to use these? For example, let's say I want to cross a river, all right? I want to cross a river, but there is a current that is going this way, okay? Then I will say maybe this is the velocity of the water with respect to the ground, okay? And I want to move with a velocity that is, let's say, whatever like velocity I'm gonna do. If I will start, if I will go heading this way, okay, then this is my velocity. This is the velocity of, let's say, boat. I have a boat with respect to the water, okay? Of course, this is not be the best option if I want to go north. I need maybe to make some modifications so that I know how I should be moving. But this is just to show you how we are going to deal with these type of situations. Okay? And here maybe one of the things that we are going to ask is what is the velocity with respect to the ground, let's say, okay? Something like this, okay? But I'm telling you here about the notation. That notation is the one that we are going to use. And here we have here, this is applied. The speed of the passenger with respect to the ground depends on the relative directions of the passengers and the train's speed. Then this is the passenger with respect to the earth. We are using here the earth. And that is the velocity of the passenger with respect to the train. And this is the velocity of the train with respect to the ground or the earth. Okay, but I prefer to use the ground. And here, as I said, it depends on the relative directions. Then if I have them in the same direction, I'm going to add. If I have them in opposite direction, then I will subtract. Okay. Now, here, I will say this should be working also with two dimensions. Then if I will imagine that that worker is going to be climbing, okay, then I will say the velocity of the train with respect to the ground is this one. And this is the velocity of the passenger with respect to the train. And then the velocity of the passenger with respect to the ground is going to be this one. Then if somebody is watching, like that person on the ground is going to see that that worker is going to be in two dimensions like this. Okay. Now, let me apply this to a boat, the one that I was talking to you about. If I have a boat speed with respect to the water is, okay, V of the boat with respect to the water is 1.85 meters per second. If the boat is to travel directly across a river, okay, across a river, then we are going to follow that route here. Whose current has a speed, then this is V of the water with respect to okay, this is the boat with respect to the water, and this one, it is, what is V? I can see, okay, then this is the water with respect to the stream. It is 1.2 meters per second. At what upstream angle must the boat ahead? How fast will be traveling across the river? Okay, now the first thing is here, we need to draw this. Then this is the boat with respect to the water, and this is the we'll say the water with respect to the stream. And I need to find the boat with respect to the stream. And the first thing we can, because we know the two velocities here, we will be able to find the sine theta, which is VWS divided by VBW. And then after that, I can also make the calculation, which is VBS equals VBW plus VWS. And that is going to be the solution. Okay, now I will say also when we will switch the variables, you need to know that we're gonna have a negative if we are going to, like, my relative velocity with respect to you is negative your velocity with respect to me. And here it is the summary of chapter 3, scalar numbers and units, vectors, quantity with magnitude and direction and unit. And in order to calculate the components, you are going to say AX, A cosine theta, and BY equals B sine. In order to calculate the magnitude, this is the formula. In order to calculate the theta, the angle, this is the calculation. Okay, and the graphical method, the component method, and just also talking about the relative velocity.